miserably. Okay, so today's 6-2 weighted graphs. Not a big deal. You don't have to write this down. But, the beginning of section 6-2, this is the opening paragraph. So, feel free to read it for a second. You have to go to the book to see figure 6.30, whatever it is. I forget. I read it this morning. I don't remember. But the weights are actually, you take a vertice and an edge and you put a number on it. The number doesn't mean like what it meant yesterday, the order that you travel around, but it means a cost, a time, or a distance of something. We're going to emulate that in a very Mickey Mouse example to start off, and then go from there. So put it in synthesized form, weighted graph. Each edge has a number on it. That number represents something relevant to a problem or relevant to like some sort of situation. We have time it takes to get from one place to another kind of questions. We have an Amtrak station question today in the notes. Planes traveling. In those cases, those would be distances that we put on the edges. Yay! Okay, so it may represent time, cost to do something, or a distance assigned to such that they are relevant. The length and edge and the weight don't have to be proportional. Or another way of writing that is, not another way of writing it, but thinking of it, geometry, drawings don't have to be to what? Scale. So look at this, 15 should be longer than 7 when you look at these two little drawings down there. Doesn't matter. It's not the point. The point is making connections and who connects with who. Blah, 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 blah. So the whole idea, and I kind of said this first hour, this is leading to this whole chapter, having a network that works best, that is the most efficient. An example I used first hour as you're writing this down, I like to rip on things. And one thing, it drives me nuts that my daughters, they have a bus stop that's at the end of our cul-de-sac, but I have to drop my daughters off a block away on the same street that my daughters are picked up, drop them off with a neighbor so that they can watch them go on the bus because we're gone. That's a different bus. It's the same road, 1 block away, a different bus picks them up there. Isn't it infuriating? So now when I have to pick up my kids, I have to drive my car over to there instead of have them dropped off on the one that's right by our house. So how that's 2 different buses, I think they have a routing problem. I really do think so. Not very efficient to have 2 buses go down the same street and pick up different kids that are right next to each other. Don't you agree with me? Okay, no, it's not Homer. Oh, I shouldn't be mentioning specific towns or people on the internet. I'm sitting in the back. All right? All right, now, here's the first one. This is great. Hey, we're back in. Pay attention.
I am.
Okay. All right. This is the hardest question. I'm going to put 7 of these on the quiz Thursday.
7. How many questions do we have?
300. It takes Voight 55 minutes to get to work from home, 25 minutes to go from work to grad school, and 30 minutes to get home from class. Draw a weighted graph. I got the vertices ready for you. 55 minutes, work to home. Boom. 55. 25 minutes to go from work to grad school. We'll call school class. Oh, wait, hold on. I didn't finish. 25. 30 minutes to get from class to home. You don't have to have straight lines. Redundant. All lines are straight. They can be little squigglies if you wanted. There's a weighted graph. Congratulations. All right, if you want notes, me too. It's my actually favorite subject matter. But anyway, If you're taking notes, I'll give you a second to write all this down. Okay. Somebody asked me when you get to the homework, you can ask me later. No, you don't have to write the charts out of the book. But go ahead and take a minute to look at this Amtrak. This is a schedule of all these cities connected to each other or not. Amtrak doesn't, I guess, not in the real world, but according to this question, of course, doesn't connect directly to Columbus. So you'd have to, if I had to go use Amtrak to get from Chicago to Columbus, I'd have to have some stops along the way. Just like that happens a lot when you're riding an airplane. You don't get to go from Chicago to California, maybe. Some might be direct, some may not be. Might have to stop at Las Vegas, then wait, and then go from Las Vegas to Chicago. One time, for my honeymoon, I had to go from Chicago to New York, and then New York to Florida. Is that very efficient? No, we went directly east and almost directly south. I don't know if directly east, but pretty close. So that wasn't efficient, but it must have been a cheaper flight. I don't know, but that was crazy. I remember having to do that. So I thought this was hilarious, and so far it's gone nowhere today. Tell you a little story. They're not listening. Blah 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 blah. Okay, so I'm watching football. Anyone football fans? Watch the England game, Indianapolis against Jacksonville. So So it was real early. I think it started like 8:30 our time. So all of a sudden my 6-year-old shows up, comes downstairs. Didn't really see her come down. All of a sudden she's on the couch. And then she's watching the game for like 10 minutes. She goes, "Dad, is it called Indianapolis because they like Indians and they like apples?" I just thought that was hilarious. I busted out laughing. I thought it was the cutest thing ever. All right. Okay, so we're stalling to get this chart done. Hopefully you see the chart. The first thing said, draw a weighted graph for this. Now what the weighted graph kind of does is give you the connections, and it sees, maybe different ways some disconnected routes could be connected. Like, how could I get from Chicago to Columbus? And I think it's set up there, find how many ways you can get from, what did it say up there? Okay, I'll move up. Nashville and Indy. Okay, so Nashville and Indy do not have a direct route. What are my possibilities? What might be most efficient? Okay, but we'll just show different ones and then make that analysis. So this will be the third time I'm doing this, and I guarantee it'll be the third different looking map. What won't be different is who lines is connected to who. So that's the thing. So this is going to go slow and be careful. Don't make a mistake. And I should just have you do this because I think you can handle it, but I'll just emulate it because that's what I feel like I should do as a teacher. Emulate what you need to do. Chicago goes to Detroit. I don't care where Detroit is compared to Chicago. It's not the point of drawing this graph. The point of this is seeing the connections I just said before. So we don't even have to worry about geographically where is Chicago and Detroit in relation to each other. Just connect them with the miles that connects them. And then Indy. I just put Indy right here. And then that is 110. So I start with Chicago and I'll get rid of its column. Chicago. And there's a dash there because Chicago doesn't go to Chicago. These dashes mean, we don't need those. I hope you understand that. St. Louis. I'll just put over here. And that's 402. And then Nashville. I guess I put that over here with an N. Now I got lost actually I did worse last hour than I did first hour, with my brain even cloudier first hour. So make sure I don't make any mistakes when I try to connect the next cities. So I'm done with this column. So now I'm going to go to the Detroit column and connect anything that's different. But I already have Detroit and Chicago connected, right? So I don't need that redone. Detroit to Columbus, do I have that one? No. Do I even have Columbus? No, because Chicago didn't have Columbus. So I might put, I hope I don't make a mistake here. I feel like I'm doing something bad here. I'll put Columbus like right here, I think. I think this is where I had a problem with my graph a little bit. So as long as I connect them, I'm fine. Sorry. And I put a 675 here. Bless you too. That was just a cough though. All right. Where did I put that? Holy jeez. There's the third mistake of the day. Oh, he's the worst. I knew it. He's a bad teacher. All right, 204. Go to Twitter. All right. Now, Detroit to Nashville. Oh, okay. This is what I got to do. Detroit to Nashville. I think I want to get it out of the way. So I just want to make that connection and then put 675 on that. Well, that's why that 675 is still down there. The graph I made last hour is a lot bigger. Okay, so kind of similar so far. All right, now I'm done with this one. Go back. Red. Done with that one. Now we go to Indy. And so on and so on and so forth. But I'll still emulate it as we go. Indy to Chicago, already done. Indy to Columbus, done or not done? Not done. So Indy to Columbus. Indy to Columbus is right here, right? And then that's only 75. And then Indy to St. Louis, do we have that one? No. So we could do that one right there, and that's 354. So you can see why you can't worry about the lengths being proportional. It'd be very hard to draw, unless you actually had a map and then connected them with, some sort of network. All right? And then we're done with that one. And then what's a different color? Maybe purple. Columbus and Detroit connected? Yes. Columbus and Indy, correct? And then that's it. We're done with Columbus? I feel nervous. Are we done all right? Yeah, okay. And then I'll use purple for St. Louis then. St. Louis and Chicago, yes. St. Louis and Indy? Yes. St. Louis and Nashville, yes or no? No. Where's Nashville's? Okay, not bad. I could do St. Louis to Nashville and do 584. St. Louis to Nashville, St. Louis to Nashville, 584, just double checking before I make a mistake. And then at the end, Nashville to Chicago is done. I go orange. Detroit and St. Louis, so they're all done. So I don't have to do anything else.
Nashville to Detroit isn't connected.
Nashville to Detroit.
Yeah, never mind.
Yeah, it is. All the way on the outside down here. Okay. Tedious. From this, you might be able to just get some easy routes now from Nashville to Indianapolis. So here's Nashville, and here's Indianapolis. So one, even though it looks longer, it's actually, I think, the shortest. If I go from Nashville to Chicago and then Chicago to Indianapolis. So one would be, keep hitting this, Nashville to Chicago, and then Chicago to Indy, and then just get its total weight, which would be its total distance. A lot, but is it the shortest? I think it might be. Because if I go this way, boom, boom, it looks shorter on your graph, but is it shorter as a distance that you have to travel? And the answer is, of course, no. Nashville to St. Louis to Indy. All right, and that would be 584 plus 354. I'm not doing a third. It said 2. You get the points, hopefully, of all this. And then that's some number we can add on our calculator. I don't think you need me for that. Or we could go Nashville to Detroit, Detroit to Chicago. Look at this. Green and purple make black. You just learned that. Nice. Blah, 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 blah. It would just be a different route. Okay, let's go on to the next stuff. Boom. Good? All right, let's keep going. So weighted graph, how you draw it, it's easy. I don't think you need me for that too much. I don't know if I've seen or said this term before, just a subgraph. You have an original graph, and from an original graph, you make a new one. You do something different. Therefore, it would be called a subgraph from the original graph. But the new term for the day is weighted graph, but then also a redundant connection. That's if an edge can be removed and can still maintain a connection between all the vertices. So I took the Mickey Mouse example from the beginning. Home to work, work to class, class back to home. This is a circuit. So we have a redundant connection. If we remove any one of these three, I still have all the vertices connected. And that's all you need to know about what a redundant connection is. Circuit is the key. To get rid of redundant connections, you remove all individual circuits, but make sure all the vertices are still connected in some way, shape, or form. Now, as this whole chapter has become, answers will, of course, what do you think? Vary. Oh, so I got to construct something that I can grade Thursday that is very easily gradable. So I got to trick myself how I can do that, because otherwise it will be a nightmare. Especially that homework was a little bit, you had big graphs. It's tough to graph, see your lines and see which directions you were going. So hopefully you know how to do that. I'll stop moving for a second. I'll just pause so people take it. Guess what? This is in the. I had to put that online. This is in the homework. Not as bad a chart, right? Okay, so no, you don't have to write the chart down on your. I don't want you to do that. I mean, if you really like doing that, that's fine. But don't overdo yourself here. So this is airlines. And then these are the same thing, kind of miles to each city. So Cleveland. And again, these dashes mean you don't go from Cleveland to Cleveland and spend $100 on a plane ticket. Okay, so Cleveland to Chicago. All right, I think you could do this. I don't think I need to do this online. I'll start taping. Okay, so I got through not much of this. And then now I have St. Louis and... What's the matter? What happened? It's just a bug, guys. So are we done with all these?
Yeah.
Right? Because St. Louis is already connected with all of them. It looks like a clown, doesn't it? Anyone? Okay. Now what I'm going to do is, and it didn't look like a clown last hour, so again, just to hammer down the point, not everyone's graph is going to look the same. Paste. I'm going to shrink it down. Oh, and then I'm going to copy this 2 more times to prove the point that answers what? Now you don't know what I'm going to do next. What I'm going to do next is what's in this this little thing and I thought I'd want to emulate this so you knew kind of how to do it. All right. Remove redundant edges until the graph no longer contains a circuit. Draw the resulting subgraph. So what we're going to do is just do that. Tomorrow this is called something. All right? It's not really a big deal. So this whole thing isn't a circuit, but we have individual circuits, don't we? Right? We have individuals. I can start where I ended. Correct? You have to remove all of those according to what this definition of a redundant edge is considered. So, can I remove this edge and still have the vertices connected? But do I still have individual circuits? Yes, I have an individual circuit here, an individual circuit here. So I need to keep going. I still have redundant edges. Can I remove this one and still have the edges the vertices still all connected? Yes or no?
Yeah.
Do I still have a redundant situation? Do I still have a circuit? So the last one I'll remove is I'll choose to do this one. Now I'm losing my vertices when I do that. I must have drawn those at the same time. Do I have an individual circuit? Yes or no? No. Stop talking if you don't want to answer the questions right. Okay? No, you do not. Are all the vertices still connected? So what this says is, one way we could do, we're running out of money. Amtrak can't run all these routes, but we need to keep these cities connected. One way we could do this is keep the Cleveland to Minneapolis. Then they'll just have to do that, and then from Minneapolis go from either St. Louis to Chicago, which actually seems reasonable compared to what I'm going to do next and what we did 5th hour. So that was just an accident. But that's why we're removing these redundant edges in case the Amtrak was about to go bankrupt. Well, what we can do is stop running some of these lines, but still have people have the ability to make these cities. I don't know. Or answers may what? Vary. Can I get rid of this one and still have all the edges vertices connected? Yes. Do I still have an individual circuit? Yes. Well, then I can get rid of this. Do I still have a circuit? Yes. Take a pick. Boom. Do I have a circuit anymore? No. Are all the vertices connected in one way, shape, or form? Yes. So this says, all right, we'll keep these, and if I need to get from Chicago to Minneapolis, I will have to go to St. Louis, then Cleveland, then Minneapolis. What? Okay, so that's definitely not efficient because of all the miles. But again, just for the purposes of this, this is what's called removing the redundant edges. One more way. Let's remove this one. Can I remove this one? Yes and yes, right? Aren't all the vertices still connected? Yes. So what I did is I removed 740 was in both of them, so I wanted to do different where 740 wasn't in it. It's just playing along. And then maybe something unique like this one. So this is another removing the redundant edges, but all the vertices are still connected in some way, shape, or form. That's all there is to this. That's what they're talking about here. Okay? All right. So I'm done. That's it. It's over. You have a homework assignment.